Okay, so this is the exponential growth and decay worksheet problem and the logistic equation problem. So we'll do problem number 6 from both of those worksheets. So let's go ahead and get started with this one. The world population doubles every 35 years. In 1980, the population was 4.5 billion. Assuming that the doubling period remains 35 years, estimate the population in the year 2120. Now, this is going to be a doubling situation where we're going to use exponential growth. And I know when we talked about population, we really look at a logistic model, but let's go and assume that it's just going to keep growing in terms of an exponential model. So when it doubles, we're going to use the formula y equals y naught 2 to the t over n. And remember that t is the time, n is the doubling period. So here we got doubling period at 35, so this is n. Y naught is the initial population. So we're going to take 1980 as being time 0. That'll be our initial population, which is 4.5 billion. So I think for this case, we're going to use 4.5 and just keep these in terms of billions. So we're going to say that y equals 4.5 billion people times 2 to the t over 35. And we're going to estimate the population in the year 2120. So what we need to do is know how many years 2120 is from 1980. So 2120 is going to be, we're using our calculator. Make sure you have your calculator, by the way. We're going to need it for our logistic functions in just a few minutes here. This is going to give us that in 2120, our time, t, is going to be 140 years, using the fact that 1980 was 0. So we're going to go and plug in t equals 140 into t here, and we're going to get y equals 4.5 times 2 to the 140 over 35. Should be kind of a big number here, right? So let's go ahead and use the calculator, and you can just go ahead and use your Inspire if you want, or whatever calculator you have on hand. So we're going to have 4.5 times, let me zoom in here a little bit, see if we can see this, 4.5 times 2 raised to the 140 over 35. And that gives us 72. So we're going to estimate this 72 billion people. Now, remember that this is your doubling period. Basically, it's how often does it double. So it doubles 35 years, every 10 years, whatever that is, how often it is, that's the period. So that's our n. Okay, so this is number 6, and we'll look at the logistic function next. Oops, let me zoom out here a little bit here. Okay, so the following table gives the size of Toronto's Jewish population through the 20th century. We've got these numbers here. I'm going to say 1901. That's going to be t equals 0. So 1911 is going to be 10, 20, 30, 40, 50, 60, 70, 80, oops, and 90. And it says find a logistic model for the data. So in order to find a logistic model for the data, we're going to need to use the calculator. So we're going to go ahead, and I hope that this shows up without the light being too much of a problem. Let's turn off the light and see if it works here. It's a little bit too dark in here. Okay, so hopefully you can see that. I know you'll probably have to look at it very, very closely. We're going to take and create a new page, and we want list and spreadsheet, and we're gonna label our first list, or first list here. We're gonna label year, so I'm just gonna type in year. And then our enter. Then our B is going to be population, so I'll enter that pop. And then we'll just enter in the data. So 0, 10, 20, 30, 40, 50, 60, 70, 80, and 90. And then enter in the data for the population. 18,294, 34770, 46751, 52798, 66773,